Okay, everybody, let's get to it. So for this problem, we're going to calculate the A, B, C, and D. So let's see what we can do here. You'll notice that I guess we'll just do them in alphabetical order. So A is right here. It goes from there to there, and so I think we can agree that A is just that length and that length combined. So we're gonna just go here and say A is 3.247 plus 9.425, which is going to equal 12.670. Oh, I gotta click on that. Okay, 12.672. And it says measurements are in inches, so I need to include my units of measurement always. I can do it that way, or I can do it that way. I don't really care. All right. Yeah, you do need to use your units always, okay? Because without the units, the number by itself doesn't mean anything. It'd be like walking into Home Depot and saying, I need 12.672. And they'll say, well, that's nice. Tell Reader's Digest. 12.672 what? They say, oh, inches. Oh, okay, now we're getting somewhere. Inches, yeah. Of what? And then you might say, well, of plywood, or well, probably not plywood, but 2x4 or piping or whatever. And so they need to know what the number refers to. All right, let's go to B. B is where? Oh, right there. There's B. So how would we get B? Well, we know the B goes from there to there. And we also know what this distance here is, which we can use. That's the 12.672 we just found. So we know that full distance there. So if we took that full distance and I cut these guys away, we'd just be left with B. So let's give that the old college try, shall we? All right, so B is going to be the full 12.672, and then get rid of the 4.868 and the 3.87. And what do we get? We get 3.934. Don't forget your units, inches in this case. All right, what is next? What indeed? Now we're looking for C. And I think we can all agree that C goes from there to there, which was C. So we've got a couple of things to add, but one of them, we don't know what it is. Okay, but we could add up all three of these, and that would be the same thing. So let's do that. All right, so C is going to be the 1.844, the 2.721, and the 2.569. Okay, what do we get? We are going to get 7.134 inches. Whoops, gotta click on that. 7.134. Okay, cool. One left. Now I got to get D. Similar to the way we got B, D is, will be obtained by just taking the entire 7.134 inches and knocking off that guy. Okay, so we go get them. All right, so D is going to be that whole 7.134 minus the 4.464, which will be 2.67 inches. And that is how we do this one. Okay, so on this one, if the drawing of the part is scaled up by a multiple of 5, find the new dimensions. So for example, well, all that means is you're going to multiply everything by 5. That's it. Just multiply everything by 5. It doesn't mean add 5. It means multiply by 5. So if it had said scale down, if it was down right there, then instead of multiplying, we do the opposite of multiplication. We do division. Okay. But we're going to scale it up, multiply it by 5, and let's see, hopefully you've already obtained a calculator of some sort. I'm going to be using my fancy TI-84 calculator. You don't have to use that one, but it does work rather nicely. Okay, so there are 2 measurements. The radius of these big circles, 4 1/8, what is it, inches? Yeah, inches. They're both 4 1/8 on the radius. And again, radius is the distance from the center to the edge. So R stands for radius. So a radius of 4 1/8, that will be, yeah, the distance from the center of this big circle down to the edge. And it'll be the same if I go that way or that way or that way or whatever. Okay. So, and then the other distance is more straightforward. This 11 3/4 is just the straight line distance between those 2 lines. So yeah. Anyway, so that's how it works. And we'll deal more with situations like this more in different ways in the upcoming future. All right, so we want to scale it all up by a factor of 5. So I'll go 5 times. Now on my calculator, I can go green, y equals 2, and then just type 4 and 1/8. I'm using these arrow keys here to navigate around. Okay, and I get that. And then I can go to the math button and say, let's turn it into a decimal, or yeah, decimal. And I get that, and I can do different things. Now, you probably aren't using a fancy calculator like this. That's okay. So here's maybe how you're going to type it. 5 times 4 plus 1 divided by 8. 4 1/8. Or maybe you're more comfortable with this, just saying 4 plus 1 divided by 8. Okay, there, I've got that number. Now I'll take that number and I'm going to multiply it by 5. And I get the same thing either way. Okay. All right, so, you know, find out what works for you. I don't care which method you use, just find something that works. And, you know, if you're just not finding something, you can always contact me, okay, about anything. Okay, so we know that the answer for one of the numbers is 20.625 inches. But, you know, when if you're getting 4 1/8 inches, 11 3/4, they're not going to want you to convert to decimals. Okay, they're going to want you to keep it mixed numbers. So we should probably do this as a mixed number. All right, well, that's why our system, the non-metric system, is such a pain in the rear. Okay, righty. So we're supposed to go 5 times 4 and 1/8. Okay, one way to do it by hand is to turn that guy into an improper fraction and say 8 times 4 is 32. So we do multiplication there. Plus 1 is 33. So I could rewrite that as 33/8. Okay. All righty. Now, I can multiply the 2 fractions together and get 5 times 33 is, let's see, it's 165. And in the bottom, 1 times 8 is 8. Multiplication is great. Okay. Now again, someone says, hey, can you scale this part up by a factor of 5 or multiple of 5? They're not going to want you to say, hey, the new radius is 165/8 inches. They're not going to want that. Okay, so we're going to, all fractions are division in disguise. So we're going to divide 8 into 165. Oops, I don't want that there. And 8 divides into 16 twice. And then we bring down the 5. And 8 divides into 5 no times. Okay, we still got this 5 hanging out here. So we can bring down a 0 and say, all right, 8 goes into 50. What is that? 6 times, blah, blah, blah. Or actually, oh, wait, I'm overdoing it, aren't I? Okay, I could just stop right there. All right, so once I got through the whole 165, dividing 8 into it, I apologize for getting overzealous there. Then I can say, well, this is just going to be 20, because it divided in evenly 20 times, with a remainder of 5 over 8. 20 and 5/8. I wonder if that really is the same answer we were getting on the calculator. Let's check it out. 20 and 5/8 would be 20 plus 5 divided by 8. And yes, it is the same thing. So I know I've done it correctly. You're welcome. Okay, and then we do the same thing to 11 3/4. Now this one's probably gonna be easier because it's using quarters, and so that's not a big deal. So so I'll just say 11 3/4 times 5 is 58 3/4. Bam. So this one's just 58 3/4 inches. And I suppose I should write that down. Okay, so 20 and 5/8 inches, 58 3/4 inches. All right. Did I write that? Yeah, okay. And that's all we got for that one. That's how it's done. So when you are scaling up by a multiple of whatever, that's how you do it. Okay. All righty then. So next, we've got a manufacturer wants to lay out the parts on a sheet of plastic in 12 rows and 8 columns. I don't know what these things are. They're kind of like razor blades to me, but whatever. So they've got this big sheet of plastic. Okay, and they say, all right, this is how many of these razor blades we can cut out of the plastic to, so we can sell them. We can get 12 rows. So 1, 2, 3, 12. And we can get 8 columns. 1, 2, 3, up to 8. Okay. So calculate the width A and the length B of the sheet that we needed to produce the parts. Okay, so what's A, what's B? All right, well, let's give it a whirl here. And okay, so A is going to be, since we're going horizontally, it'll be this horizontal distance right here of each part. Okay, 12.682, but there are going to be 8 of them. Okay, in each row. All right, but that doesn't give us the full width A. Okay, because there's that gap in between. And the gap is 0.15 inches. Ooh, it's all decimal. That makes it easier. Okay, so there's a 0.15 inch gap in between them. Now, how many gaps are there? Well, it turns out there are only 7 gaps. One, hang on, let me shift into that right there. Okay, so we got 1, 2, 3, 4, 5, 6, 7 gaps in between them. Okay, just one less than the number of razor blades. Okie dokie, so that's going to equal 102.506 inches. Okay. All right, now what about B? B is going to be very similar. B is the vertical distance on this plastic sheet, and the vertical distance on an individual razor blade is that 6.145. And there are going to be 12 of them in a column, plus 15/100ths of an inch gap in between each of them. How many gaps? Well, 11. And that's going to give us 75.39 inches. All right. So the follow-up question is, whoops, that's not what I wanted to do. How many parts will this design produce? Oh, well, don't overthink it. Okay. It's going to be 12 parts in a column times 8 parts in a row. That's going to be 96 parts that can be produced. That's it. So that's the answer to the second one. So that's how we do it. Okay, on this one, scientific notation is a number between 1 and 10 times the power of 10. So for example, 8.3 times 10 to the 4th, that number is in scientific notation because this is between 1 and 10, and it's multiplied by 10 to some power. How about 29 point, well, I don't want to do another 3, that's silly, times 10 to the -7. That is not scientific notation. It's totally fine to have a negative exponent, but this number is not between 1 and 10, and that is what disqualifies it from being in scientific notation. Okay. So that's kind of the idea there. Now, engineering notation is similar. Modification where the number is between 1 and 1,000 instead of 1 and 10. So there'll be up to 3 digits to the left of the decimal point. And then it's times 10 to some power. So we've got some numbers here, and we're supposed to convert them into various notations. Okay, so we're supposed to fill in all the boxes, and it's super cool. I don't know if I'm going to do them all or not, but I'll do at least some. Okay, so we start off, for example, on this one, 12,300 ohms. If you don't know that's ohms, that's fine, doesn't matter for this particular problem. In scientific notation, what we would do is we would take the decimal point in the number and say, all right, which way do we move it to end up with a number between 1 and 10? Well, if I move it to the right, the 12,300 gets bigger and bigger, so that's not going to cut the mustard. So I got to move it to the left. Okay, if I stop there, I've got 1,230. That's not between 1 and 10. If I go a couple more, I've got 12.3. That's not between 1 and 10, but it's close. If I go there, I get 1.23. And how many bumps are there right there? There are 1, 2, 3, 4 bumps. That's where this 4 comes from. Okay. Now, because we started off with a number that was big, 12,300, and we ended up with one that was a lot smaller. To compensate for making it smaller, this number here is positive. Okay, and that positive exponent lets us know, oh, this number is actually quite a bit bigger than it looks like. It's actually, a lot bigger. Okay, so we got that. Now, that's scientific notation. Let's do this one on scientific notation as well. Then we'll get to these guys. So over here, we want to end up with a number between 1 and 10. So I got to move the decimal point to the right this time. So 1, 2, 3, 4, 5. Right there at 7.2 gives me a number between 1 and 10. Okay, cool. And I've got 1, 2, 3, 4, 5 bumps. So there's a 5 there. Cool. But we started off with a really small number and we made it bigger. But this is supposed to be equivalent to what we started with. So to compensate for having made the number bigger, we put a negative on the exponent to say, okay, this number is actually a lot smaller. Okay. So you kind of see how that goes. All right, so that's scientific notation. Let's do, I don't know, this one right here, I guess. So I got to move the decimal point to the left to make it smaller. 1, 2, 3, 4, 5 bumps. Okay, and I'm gonna have to use my typing thing, otherwise I'm not gonna be able to fit it all in there. Okay, so that'll give us 4.8 times 10 to the positive 5. Okay. And because we had a really big number, we're making it a lot smaller. So to compensate for making it smaller, we have a positive number to say, hey, you know, if we were multiply this out, it actually gets quite a bit larger. Okay. Whoops. Go on, get rid of that. Let's see, where's the eraser? Right there. Cool. Okay, so what about engineering notation? How the heck does that work? Well, engineering notation, you might notice that the exponent is always a multiple of 3. Okay, so that's cool. But like they said over here, the number out in front always needs to be between 1 and 1,000. Okay, and the exponent be a multiple of 3. So yeah, this is between 1 and 1,000, but the exponent is not a multiple of 3. Okay, same thing with that one. That's between 1 and 1,000, but the exponent is not a multiple of 3. Okay, cool. So, so to get this, they said, well, let's take the decimal and go 1, 2, 3. Okay, there. So that's 3 bumps. And so if we stop there, that'll give us our exponent will be a multiple of 3. But does it give us a number between 1 and 1,000? Well, it gives us 12.3. So yeah, we're okay. Okay, on the next one. Let's go 3. 1, 2, 3. All right. Does that give us a number between 1 and 1,000? No, it gives us 0.072. That's not between 1 and 1,000. All right, so let's go another 3. 1, 2, 3. Does that give us a number between 1 and 1,000? Yes, it gives us 72.0. And so we've gone 6 bumps in the negative direction. So we get that -6. All right. So what about this little piggy right here? Well, let's go 1, 2, 3. Does that give us a number between 1 and 1,000? Yes, it gives us 480. So, we'll say 480 times 10 to the, there's 3 bumps, so 10 to the 3rd. All right. And that's how we do it. Cool. Now, what about this last column here? The last one there is going to be just rewriting whatever is in the engineering notation column, but with a fancy prefix like the K for kilo or the mu for micro. I know what you're thinking. I don't really have that information. That seems kind of unfair. And you're right, it is. But we have that down here within the same problem. Okay. So times 10 to the 3rd power. Okay, 10 to the 3rd power, that's just a 1 with 3 zeros after it. Okay. 10 to the 3rd power is right here. And anything as 10 to the 3rd power is kilo something. And we use a K to represent kilo. All right. Whoops. There, I'm in the right spot. And so we will say, all right, this using the engineering notation column, 480. And instead of saying times 10 to the negative third, I'm going to replace 10 to the negative third with the K for kilo. Okay. And then the kilo what? Well, the units were HZ, hertz. So kilohertz. All right. And then that's how it's done. If we had something like 10 to the negative 9, maybe 10 to the negative 9 is going to refer to nano, and you just use an n instead. Replace the 10 to the negative 9 with an n. 10 to the negative 12 gets replaced with a p for pico. And that is how you do it.